welcome back. This exam season, bit troublesome. Yes, because revision is the major key, but for revising, we people will be using one-shots. The one-shots will be longing for like more than 1 hour or 2 hours, right? So bit wasting of time. So here comes a smart solution where you are going to warm up all your units just in 40 minutes with most highlighted points and important formulas. Yes, Pasangla, don't miss this chapter, don't miss this series. And if you want to see the long version one-shot video, detailed lecture on each and every unit for physics, then you have to visit our channel and you have to visit our playlist where you can get the complete file for your units. So let's get started. This is your 40 minutes lecture, maybe 35 to 45 minutes. So I hope I will be completing it in 35 minutes. So let's get started. This is your first thing which you have to revise. Electric charges. So electric charges are two types. One is positive charge and one is negative charge, and negative charge will be transferring from one body to the other, right? So we people know like charges will be repelling each other, and unlike charges will be attracting each other. Unlike charges will be attracting each other. And here, whenever we discuss the positive charge and negative charge, it doesn't mean it has a direction. It only means its nature. So we can conclude that charges are scalar quantity. Okay, and charges are like invariant. Even if we change the frame of reference, it won't change like our motion. It is completely fixed. Positive will be positive for all long and for all frame of reference. Okay, so this is a major thing that you have to understand. So it is invariable for time or frame of reference. Nothing can change that. And now the next important point is the least value of a positive charge or a negative charge will be like 1.6 into 10 to the power minus 19 coulomb. It is a very important unit which you have to understand. And the next important point is it is additive. The charges are additive in nature. These are the basic properties. Yes. What is meant by additive? So whenever there is a body of charges, minus 3 coulomb and plus 2 coulomb of charge, you have to add the entire charges present along with the sign. So this will be like minus 3 plus 2, so you will be getting minus 1 coulomb as your answer. Done. The next one is charge is conserved. So charge is conserved in the sense before a process, after a process, before transferring of charge, after transferring of charge, then total charge, the net charge of the body doesn't change. Okay, maybe there might be happening some charge transfer, but the entire net result of total number of charges for each and every body will remain constant. So that means the charges are conserved. And the next one is quantization of charge. For a bit example, if you have 10 rupees, so what is the minimum rupee that present in 10 rupee? That is 1. So that is valid right now, right? So 1 rupee. If I need to have 10 rupees, then what I have to do? I have to collect 10 number of coins in 1 rupee. So I can get 10 rupees. If I need hundreds, then I have to collect 1 rupee coin 100 times. Then only I can able to get 100. So this is quantization. So quantization of charge simply represents 1 coulomb of charge doesn't mean it is 1 charge. It is like a bucket. So you have to pour n number of charges into it so that you can get 1 coulomb of charge, and practically 1 coulomb of charge is a hell value. Pasangla, millicoulomb, microcoulomb, that's why your questions are mostly will be like 1 microcoulomb and millicoulomb structures. Okay, so understand that better. So quantization is nothing but integral multiple of, okay, 1 coulomb doesn't mean it has only 1 positive charge or only 1 negative charge. It is a tons and tons of electrons, charges will be present in it. So for example, so n is nothing but integral multiple. So it will be like a whole number, okay. So 0, 1, 2, 3, etc. It cannot be like in fractions or in decimals. So that is not possible. Okay, so that is why we have given here, we have already mentioned it here, charges least number, it can't be again divided into anything. So if it is in decimal, if n is in decimals, then that means it is divided again. So you can't take. So you can buy only 1 egg, you can't buy half egg. So that is what mentioned here. Okay, so charge is nothing but integral multiple of its least value. That's it. Clear? Yes. And for example, if 1 coulomb of charge you are talking about, then that 1 coulomb bucket should contain how many charges? 6.25 into 10 to the power 18 electrons to be filled in that bucket to get 1 coulomb of charge. So from here we people understood that charges are not like 1 coulomb for 1 electron, 2 coulomb for 2 electrons. It is not the case, right? Now let's roll for the next one. Yes, this is the basic thing you have to understand, because for charge conservation and everything there should be some process, right? So we people know atoms have free electrons, which is valency electrons. With some special energies we can excite the electrons and we can bring it out, right? So what here happens is, while rubbing two metals or two objects, what happens is suddenly you could feel static electricity. So that is a most widely talked topic, okay, and discussed topic in Bangalore before few months. So that is what here happens, okay. So a charge, a body will be containing some of the charges, okay. So what happens when I do some process like rubbing the two objects or like heating, when I do some process, what happens? Electron transfer occurs from one body to the other. So the body which has high amount of free electrons will be delivering, will be transporting some of the electrons to the body which has less number of electrons. So if A is transferring to B, then that means A is having highly concentrated electrons, negative charges, so it is transferring into the B. Okay, this is the first point. So after transferring, what happens? Here electron count will be reduced, here electron count will be increased, right? So if electron counts are reduced, then what that does means? That means it has less mass, right? So it loses electron. So loss of electron happens here. Loss of electron happens here, and here gaining of electron happens here. Okay, gaining of electrons happens over here. Then the most important point is, in this body A, if electrons are moved out, some of the electrons are transferred, then your proton will be in number, in high number, right? So your positive charges will be in high numbers than your negative charges. Here your electrons will be in high numbers than the positive charges. So we could say completely this object now becomes positively charged body, and this becomes negatively charged body. Okay, and here the particle, the object which loses electron will be considered as loss of electron, and mass will be reduced. Okay, mass will be decreasing because electrons are moving out, right? Some of the electrons are moving out, and here electrons has been received. So if we are receiving electrons, then automatically your mass will be increasing. Your mass will be increasing. So these are the two things you have to understand. For transferring such electrons, we need a method, right? We need to increase their normal energy level. We have to give some input so that the electrons, then negative charges, will get excited and it can transfer from one object to the other. So there are three methods for your charging. So this one, first method is friction, second method is conduction, and third method is induction. So conduction is nothing. First let us talk about induction. So induction is the process that is widely that is used in insulators. So insulators are the materials, we people know insulators. So insulators are the materials where you have very few number of free electrons. Okay, so it can't be a conductor, it is not a good conductor, so we need to give friction. Friction is like rubbing two hands together. And the next one is conduction. So conduction is like while in contact. So we will be bringing two objects together in contact, and we won't do anything, only by simple contact. Okay, while bringing to contact both objects, there will be a transfer of charges. And the next one is induction. So induction will be like without contact. Okay, this will be like without contact. Induction, what it will be happening? So if we bring an object, which is positively or negatively charged, the other object, what it will do is, there happens polarization. So the object will be containing both positive and negative charges. But here when I bring that particle near, okay, when I move this near, but I'm not touching it, I'm just moving closer, I'm just making the object to move closer. So what happens? So there will be a polarization, okay, the charges will be splitting among itself. So it can be like positive and negative and positive. So it will be like, see, so this is negatively charged, this is positively charged, so they are aligning. So this alignment is called polarization. So that happens, and after that we can remove whatever the charges we need. If I want to remove positive charges, then I can earth it. So what happens? The positive charges will be moving up, and this object from neutrally charged to negative charge will be happening. Right? So neutrally charged in the sense the amount of positive charge and negative charge both will be like equal. So that is a neutral body. Clear? And these two things, okay, conduction and induction will be happening in the conductors alone. Okay, so conductors will be carrying both conduction and induction for the charge transferring. I hope these details are clear. From here, we will be moving to Coulomb's law. But now, before moving to Coulomb's law, you people have to understand one thing. This Coulomb's law is applicable to only the point charges. Okay, so point charges are very simple. So the charge dimension should be very smaller or very lesser when compared to the distance of separation. So two equal, it might be equal, it might not be equal magnitudely. So it can be like like charge, it can be unlike charge. So whatever the condition, if 2 point charges are separated by a distance, then there occurs mutually force of attraction between them or mutually repulsion between them. So in electrostatics, the charges will be at rest, which means we won't be like moving anything, the charges won't be moving by itself. Okay, so this is why this is called as electrostatic. Static means electric charges are at rest. So we won't be giving any potential, we won't be giving any velocity, or it won't be gaining any velocities. Okay, that is very simple. So if the charges are gaining velocity, then it will be taking you to the current electricity unit. If the charges are oscillating or accelerating, then it will be taking you to the 8th unit, where you will be discussing EM waves. So now listen. So there are two charges, positive or negative, doesn't matter, separated by a distance. So it might have force of attraction if they are unlike charges, and force of repulsion when it is like charges. So here comes you the formula, which is very simple, which is K Q1 Q2 divided by R square. So R square is nothing but the separation. Okay, and this is the separation. From here we can conclude that R is directly proportional to modulus of the charges. So you need not to mention any of the charge nature there. Positive charge, negative charge, you don't need to mention anything. And F is inversely proportional to the R square. So this is a scalar representation. Okay, if you want to write the same Coulombic force in a vector representation, then this is the only way, which is Q1 Q2 divided by R cube into R vector. Okay, so if you want to mention this in a vector notation. Clear, right? And what is K? Ma'am, K is nothing but your constant, proportionality constant, because if you want to remove the proportionality symbols, then you have to add a K, right? You have to add some constant. So that is K. So K can be written as 9 to 10 to the power 9 Newton meter square per Coulomb squared. And this also have another formula, which is 1 divided by 4 pi epsilon naught. Epsilon naught is nothing but the medium present between these charges. Okay, so medium present between these charges, because if your classroom is completely like without teacher, only you people are there, then you people are going to be the king and queens, right? So you will be shouting, we will be just enjoying it to the core. But when there is a teacher, even for drinking water, we will be asking permission, right? Ma'am, shall I go for the restroom? Shall I drink? I need to take notes, please wait. So everything will be like controlled. The similar way, it is a force. So if it is any medium present over there, for example, if it is a water or mud, whatever it may be, if any other medium is present, oil, kerosene, whatever, okay, then the force will be like they have to get permission, they have to be like, they can't be like more strong like air or in vacuum. Okay, so air or vacuum like the least controllable thing, they can do whatever they want in air and vacuum. So don't forget that. Okay, Pasangla. And the another one important formula is that is your dielectric constant. Dielectric constant is nothing but your epsilon torr. Epsilon r is nothing but your relative permittivity, which is epsilon m divided by epsilon naught. Okay, and you have to understand epsilon is inversely proportional to force F. So here it comes F divided by F. Okay, so this is the most important keyword which you have to understand. So in a medium, the force will be reducing. Without medium, the force will be like K. Okay, yes. And the force between multiple charges. So Pasangla, whenever they are mentioning it, there are multiple charges and you have to find a force in particular charge, then you can go for simply superposition. You can add all the forces present. But when you are plotting, okay, so when the charges are given, if they are asking, for example, like if there is 4 charge, they are asking the force in this charge, okay, then what you can do, you have to plot the forces. So whether it is attractive or whether it is repulsive, if this is all are positive charges, then definitely it will be repulsive. So here comes one force, here comes one force, and from this charge you will be getting another force over here. So the net charge lies here, right? So you can use vector algebra, vector addition, like a parallelogram law of addition. So where you will be getting the net force can be written as root of F1 squared plus F2 squared plus 2F1 F2 cos theta, right? Theta is nothing but the angle between two forces. So you can use that and you can figure it out. So while plotting the directions, while you are plotting the force, just be cautious, okay? Yes. And the next one is your electric field intensity, which is nothing but electric field. Because Pasangla, Franklin Benjamin have already mentioned that this is nothing but a concept of field. Yes, because we people are discussing both like charges repel each other, unlike charges attract each other. How do they know? Okay, this charge is present near me, so I have to attract. This is in my boundary, I have to repel. So this is unlike charges, so I have to attract. So everything, all these things make sense when you talk about a boundary. So if a charge has its own boundary where it can have all its force and everything, power, it can show all its force and power. So if a charge is entering into a boundary, then it can understand, then it can identify, okay, an unlike charge is coming into my boundary, so I have to attract it. No, it is a like one, so I have to repel them away. So this is the concept of field. Okay, so we are mentioning it as in a straight line and making it as like field lines. Okay, so here we can write two formulas. One is like E is electric field will be equal to electric force divided by Q. Q is nothing but your test charge. Okay, the charge which is moving inside another charge's field. Okay, that will be a test charge. Or else what I can do is I can expand the force. So Q divided by R square into Q. So one is the charge which is having the field. Okay, the small q will be like the charge which is entering into the field. So I can cancel this together and I can write this. So A will be equal to KQ divided by R square. So electric field is completely depends on, okay, electric field is completely depends on the source charge, okay, the source charge where electric charges are originating, okay, which is responsible for the electric charge, and the unit will be Newton per Coulomb. Okay, so but force is nothing but force is between two objects, right? Force, both objects should experience that. So it is between both objects. Okay, so these are the 2 points you have to remember. And now some of the properties of your field line. The first property is it starts from positive charge and it ends in negative charge. Okay, and the direction will always gives us, okay, so gives by the tangent. So we people know there might be like curved lines of fields. So what we will be doing while plotting a tangent to that field lines, we can know where it is heading. So where the field lines are heading. So drawing a tangent to the field lines will be giving you the direction of it. And the next one is both field lines, two or more field lines cannot intersect each other. If they are intersecting each other, it will be gaining two directions, which is not healthy and which is not appreciable, which is not practical. So it is not possible. The next one is normal to the surface. Yes. So whenever there is an object and that object contains charges, so the electric field from that object should be like 90 degree from their surface. Okay, it should originate as 90 degree from the surface and it also ends like 90 degree to the surface. Okay, so you can't draw like this. Even if it is an emergency, you can't draw like this, and this is the most important questions from your board exam. And field lines will be giving you the strength. Exactly, if there is n number of field lines, so you can figure this area contains more closeness in the electric field lines and this area contains less closeness in the electric field. So this area will have more electric field strength of attraction or repulsion when compared to this last end. So these are the properties you have to understand. And now here comes you the topic called electric flux. when your electric field is passing through a unit area. So when we are counting, because we need to talk about strength and everything, right? So if an electric charge, if number of electric field lines are crossing okay, from a surface area, then that will be calling it as flux. So how many electric field lines are crossing or moving across a surface area, a particular unit area, then that field lines will be considered as electric flux. So here the most important thing is you people need to know this electric flux is a scalar quantity, and this scalar quantity will be written as EA cos theta. Okay, EA. If it should be like a vector scalar, if we need magnitudes, then EA cos theta. Okay, if you want to mention it in vector, because when we are dotting two vectors, it will be giving you a scalar quantity, right? E is nothing but electric field, A is nothing but the area vector, and area vector should be drawn perpendicular to the surface, and it always should point the outwards. Okay, it should always move outwards to the surface. So if you see here, these two are like parallel to each other, and here it is like anti-parallel to each other. So if it is parallel to each other, then you will be getting positive maximum flux, and if it is a negative, so if it is anti-parallel, so you will be getting a negative value, which is maximum. So when it will be 0, ma'am? When your electric field line and your area vector is 90 degree, that is theta is 90, because here flux is completely ruled and owned by cos theta, right? If it is a continuous shape, if it is a continuous surface, if it is like a complete dimensional thing, then what we will do, we will take a small area and we will figure out flux over there, and while integrating you can get it for the whole area, right, whole surface, and the unit will be Newton meter square per coulomb, right? Yes. So the next one is dipoles. So electric dipoles are simply represented as equal magnitude but opposite in nature, are separated by 2a of distance. Okay, 2a or a, doesn't matter. If it is mentioned from origin, then you have to write 2a. If it is not mentioned from object, it is completely a distance between positive and negative charge, then a is enough. Okay, so this is called as electric dipole. So here the dipole moment will be always from negative to positive. Okay, so which is completely opposite to your electric field, and the formula for your dipole moment will be P is equal to Q into 2A, or it can also be written as Q into A, and the unit will be like coulomb meters. Okay, the unit will be coulomb meters. So while using this electric dipole, they will be asking you a question, because of this dipole at a particular point, what can be your electric field? So here we will be discussing 2 points, one is axial, another one is equatorial. So here the formulas which we people are going to discuss is completely for shorter dipole. Shorter dipole in the sense your dipole length is very smaller when compared to the point where you are going to measure your electric field. Okay, so your D will be always lesser than R. So that is called a shorter dipole. Okay, so now you can figure out, we are going to measure a point P over here. Okay, which is axial, completely axial to your dipole. Okay, so here the formula is going to be like E is equal to 2p divided by 4 pi epsilon naught r cube, but it will be simply written as 2kp divided by r cube. So P is nothing but electric dipole moment. And now the next one is equatorial point, which means it will be perpendicular from your dipole. Okay, so whenever we are measuring an electric field perpendicular to the dipole, then this is going to be your formula, and here it mentions a negative sign because here the net electric field will be opposite direction to your dipole. But here both will be in same direction, so no negative is given. Okay, so here Kp divided by r cube. So simply we can address this as, so electric field axial will be equal to modulus of 2 into modulus of equatorial electric field. So this is a simple thing you have to understand, right? Then if you people are placing this dipole in a uniform external electric field, okay, uniform in the sense your all the field lines will be completely parallel, so which will have equal strength everywhere. Okay, it will be having an equal strength. So what happens is, if you are placing a dipole in an uniform external field, the dipole tends to align itself. Okay, it will be aligning itself to the electric field, because this will be originating from positive and this will be ending at negative. right? So negative charges will tend to align parallel to your electric field, and the same goes over here. So when it is aligning, so that is called as torque, right? Torque is nothing but an analog of your force in linear mechanics, right? In your linear motion. So this is why it is called as torque. So for torque equation, we can write P cross E. We can write like that. Okay, so P is nothing but your dipole moment, E is nothing but your electric field. So if you need only the magnitude, so P is sine theta. Okay, so if theta is like 90 degree, then it will be maximum. Theta is 0 degree, then it will be 0. Okay, understand that. And now here we go for your Gauss law. Okay, so Gauss law is very important concept for your survival. Okay, because it is a most high weightage topic, and everyone used to feel like Gauss law is like an alienated topic, but it's not an alienated topic. It is an easy one. Understand a thing better. Gauss law always supports Coulomb's law. If Coulomb's law is wrong, then Gauss law will also wrong. You can derive Gauss law from Coulomb's law, and you can derive Coulomb's law from Gauss law. Yes, so this is completely to support your Coulomb's law. So how they are supporting in the sense, so whenever we are talking about forces between charges, electric field between charges, we people are talking about one or two charges. But practically in this dimensional world, we will be having one-dimensional, two-dimensional and three-dimensional object around us. So each and every object, if it is a metal, if it is a conductor, it has charges on it. So how we can find the force and how we can find the electrons, electric charges, whether by counting each and everything? No, it is not possible. So what he did is only by analyzing. So whatever the dimensional object, you can able to find your electric field if you can able to find your flux. So for finding flux, Gauss gives a very simple equation, which is Q divided by epsilon naught, which means you can have a container, you can have what dimensional object you want to measure, you can have that object. So for example, I'm using a sphere. I need to know the electric field. So what I'm going to do is, you have to place the charges inside. So when your charges are inside, what happens? Its electric field will be passing through it, right? So this imaginary sphere, this is called your Gaussian surface. Okay, so the imaginary sphere, what happens? This looks like the electric field is passing through a particular surface area, which will be resulting you in a flux, right? The simple concept. So if you get flux, then definitely you can able to find your electric field, because flux can be written as Ea cos theta, right? So this is the major idea for Gauss. So that's why he mentioned it. And you have to note one important limitation of this, or important property of this, which is you cannot, okay, here Gauss law does not depends on, okay, your Gaussian surface, okay, Gaussian surface dimensions or objects dimension. Length, breadth, height, radius doesn't matter here. Here by Gauss law, your flux will be completely independent of dimensions and completely dependent on charges present inside the surface and the permittivity, which means and the medium between them, okay, and the medium there. So what is the medium? Whether it is a water medium or air medium, so the medium, okay, the permittivity. So this is the very simplest explanation for your Gauss law. By using this Gauss law, we people can also support like 1 dimension, 2 dimension, 3 dimension objects. So here you people have to understand a thing. So wait, because in dimensional object we will be having tons and tons of charges. So what we will be doing is, if it is 1 dimension, which will be called as linear density, linear charge density, that can be written as charge divided by length, okay. So which means it can be a very high length object, doesn't matter, but I will be finding charges for a particular unit and I can integrate it and I can add everything. So that will be simple. So Coulomb per meter. And if you're talking about 2 dimension, then it will be sigma. Sigma will be like Q divided by area, which is C divided by meter squared, okay, area. And 3 dimension in the sense, that is rho, which is Q divided by V, C divided by MQ, okay. So V will be volume. Okay, so these are the 3 important charge densities you have to understand. And most important thing which you have to understand is, for any conductors, the charges will be present on the surface. It will not be stored like we are storing sugar in a container. It won't be storing charges like that. The charges will be completely on the surface. Okay, it will be completely densed on the surface. So remember that for conductors. For insulators, it is different. It is different. Okay, so here we people are going to talk about long infinite wire. So in question they might be asking long wire or infinite wire. These two will be representing only one meaning, which means B doesn't know the origin and B doesn't know the ending. Okay, it is infinite. So what I'm doing is I'm going to draw a Gaussian surface around it, and according to that Gaussian surface I can able to find what the electric field can be for this rod at a particular point. So here the simple thing is lambda divided by 2 pi epsilon naught r, but what I'm going to do is this is 2 by 2, I'm multiplying and dividing the entire equation with 2. So what happens, 2 lambda divided by 4 pi epsilon naught r. So I can write 2k lambda divided by r. Lambda is nothing but your charge, linear charge density. Okay, this is for your uniform long straight line, okay, or infinite straight line. Now here comes your two dimension, that is your infinite plane. Okay, so infinite plane sheet. So if it is infinite plane sheets, then it is very easy. Ma'am, it is a square. Yeah, what's wrong with that? You can draw your Gaussian surface and you can deduce the formulas, right? If you want to visit the derivations for each and every concepts discussed here, then you have to go and watch our one shots or end-to-end series in our playlist. That will be helping you, and the people who doesn't subscribe the channel till now, do it now and share this with your friends, and just put a heart on the comment box. Okay, let's get started. And the electric field will be like E is equal to sigma divided by 2 epsilon naught. Sigma is nothing but the charge density, surface charge density, and epsilon naught nothing but the medium. So this shows the electric field in an infinite plane sheet does not depend on any of the dimensions. Whether in this case it is completely depend on the dimensions, which is inversely proportional to the radius. So if I plot the graph, it will be like E and R. So you will be getting an inverse graph. But here this is not the case. So whatever the dimensions of the object or the Gaussian surface, it doesn't matter. Okay. Yes. The next one is the shell or hollow cylinder. Everything are the same. Okay, everything are the same. When it comes to shell, we will be identifying it in 3 points. Okay, we will be identifying it in 3 points. One is within the cell, on the surface of the shell, and outside the shell. So your Gaussian surface will be like 3 different radius that will be represented as your small r. So small r will be representing your Gaussian surface dimension, and capital R will be like your normal dimension for the spin. So whenever I am discussing it outside the cell, so just remember a simple formula, which will be like Ke is equal to Kp divided by, okay, sorry, Kq divided by R square. Okay, you can simply remember this formula. Okay, this is a simple way, and R is nothing but your radius of your Gaussian surface. For R is greater than capital R. This is outside the cell. If I wanted to discuss on the surface, then your R will be equal to R, right? Gaussian surface and the object will be the same. So what happens over here? This will be Kq divided by capital R square. If it is inside, then you will be getting it 0. As I mentioned earlier, the charges on the conductor will always reside on the surface, not inside the surface, so it will be 0. If you want to mention the equation in density, right, if in surface charge density, then you can use this formula, which is widely used, but may or may not be asking in your exam, but these 3 formulas are very important, remember that. And also we people can plot the graph like this. Okay, so it will be 0 inside, and on the surface it will be maximum, and again it will be reducing. This is the surface, this is lesser than the our dimension of the sphere, and this will be greater than the dimension of the sphere. Clear, right? So these are the concepts you people have to understand much better, as we already discussed inside the sphere. So Pasangla, I hope you really literally enjoyed this session. It is a very easy and quick revision for your basic fundamental highlighted points and formulas. So if again I'm stressing, if you want to study from the scratch and you want a detailed explanation on everything, then you people have to visit, you people have to watch our one shot and end-to-end series on electric charges and fields. Not only that, we have marathon manada, there are many series that will be giving you an exact and extraordinary explanation for each and every chapters. Okay, with derivations and without derivations are also available. So don't miss this and make this warm-up session as your eye opener, and like use it for your revision purpose. Okay, make a flow chart and make a formula sheet, study with that and work out numericals. Okay, so you people, you can also watch Numerical Express. So these are the things will be helping you to boost your score for your upcoming exams. I hope we did best in our session. So and now this is time for me to say thank you. So Pasangla, take care everyone. Have a great day. And I will be seeing you in the next important session. So if you people are excited for your next chapter, so comment me on the comment section what chapter I would take for your warm-up next time. Okay, and also don't forget to subscribe the channel, share the channel with your friends, so you people can able to, they can also able to feel the rhythm of studying class 12th with us. Okay, so yes, so like the channel, like this session and subscribe the channel. So and also turn on the notification, okay, so that you can get you can always be notified by the YouTube that we are coming live. We are just going to post an important session for you people, so you will be always on the limelight. Like, okay, so thank you so much, Pasangla. This is me, your Shobika ma'am. You people know when Shobika ma'am is here. Right, have a great day. So see you soon. Take care everyone, and all the best for your exams.